Hello and good day, Fox!
Thank you, math assistants. The purpose of today is to go over that geometry. Shut the door! The geometry entrance exam review packet, so that you have kind of some way to jog your memory as you're going through the packet, and those concepts that are a little bit rusty, not quite familiar with. Not going to go over every single question, but at least get that light bulb flickering. That is the goal here. So here's the general information about it. The purpose is to shake off that rust of summer and those most important concepts from algebra, making sure those are still fresh heading into the school year, because, well, you're going to need to use them. The review packet is optional, will not be graded. The entrance exam, just like last year, will be graded on the number of objectives passed. Each objective will have 3 questions, and getting a 2 out of 3 correct is considered passing that objective. There are 20 objectives, so 60 questions on the exam, and the exam will be worth a total of 20 points. You'll do the entrance exam during the first week of school. You may use a calculator on the exam. Last year you could not. This year, just with the heavy stuff that algebra carries, a calculator is allowed. I forgot to mention, any objective that is not passed, you'll need to practice and retake before the end of September. Again, just like in 7th grade. You may use a help sheet consisting of definitions, formulas, reminders of important information, etc. You just can't have any worked out examples. To review objectives, obviously watching this video is going to be helpful. You can also search for them on Khan Academy, the Google, last year's binders, or you can go to the lesson for the objective, the actual lesson, on my YouTube channel. And of course, don't forget to like and subscribe. Answers to this review packet will be posted on the bulletin board in Blackbaud on Monday, August 29th. And my email box, inbox is always open. Please feel free to shoot me one if you've got other questions I can answer. So again, we're not going to go over every single question here, but just to give a general idea of what the concept is about, and then you can take it from there, how much more you need to research it. So order of operations, off to a great start here. Got to see that. Order of operations, PERMDAS is the order, parentheses, exponents, radicals, multiplication, division, addition, and subtraction. And then, let's pick one, number 3 here. This looks like a fun one to do. So we start with the parentheses, but within the parentheses, we've got that power, that 2 squared. So we can rewrite this to be 6 plus 8 plus 2 squared is 4 times 2. Next, we would do parentheses. That brings us to 6 plus 12 times 2. Multiplication would occur next. So 6 plus 24. And ultimately, 6 plus 24 is 30. So as you're going through these, just follow the order of operations, and you should be fine. Next objective, what do we got? PO7, solving multi-step equations. So this objective kind of covers everything from combining like terms, like we have in the first one here, 5a and negative 3a. We have 5a's. We lose 3 of them. We're left with positive 2 of them. And then now you have a 2-step equation to solve from here. Opposite operations would be the recommended method. The second one, we've got parentheses, which means we need to distribute, right? So negative 8 times negative 2x is a positive 16x. Negative 8 times positive 3 is a negative 24. That equals negative 88. Okay? And again, you're left with a 2-step equation to solve there. The third one is kind of a combination of combining like terms and distributing. When you distribute, make sure that you're putting in the negative 3, right? Negative 3 times 6, negative 3 times negative 2c, and then combine your like terms after you distribute. Number 4 involves variables on both sides. So remember, it doesn't matter which side of the equation you move all your x's to. You can move your negative 13x's over here, and you do so using opposite operations. Or you can move your negative 17x's over here, and again, do that doing opposite operations. So it doesn't matter what side of the equal sign you move all your x's to. but whichever side you choose, make sure that you are using opposite operations to do it. And of course, check your answer, right? That's the easiest way with an equation to see if you've done it correctly. Whatever value that you get for the variable, plug it back in to the original equation and check to make sure it works. And some word problems, because why not? PO9, writing and evaluating expressions with exponents in standard and expanded form. Basically, this is testing your understanding of what an exponent means. And an exponent means repeated multiplication. So 4 to the 5th power means 4 times itself 5 times. 4 times 4 times 4 times 4 times 4. Mathematicians, instead of writing that, they said, well, we can just use a power instead. We're taking 4 to the 5th power. It just means that you're multiplying something over and over and over again. When you have a variable, in this case, an n, I've given you the value to be 3. And so when you write this in expanded form, such as number 4 here, you've got 9 times n. Remember that according to the order of operations, that exponent only applies to the base, only applies to the n. There's only one of the 9. That's a coefficient, right? So 9 times n, you'd replace that n, each of them, with a 3 per the directions up the top of the page. And then to evaluate this, 9 times 3 times 3, it would be 81. Okay, so wherever you see an n, plug in a 3 and evaluate it that way. But just be very careful when you're writing these out in expanded form. Pay attention to what is a base, what's a coefficient, what's in parentheses, things such as that. And that leads us to our other objective on exponents, all those exponent rules that we learned last year. You've got multiplying by the same base. You've got a zero power property. I'm realizing now I forgot to put the multiplication symbol in between 3x to the 0 and 2x to the 7th. But what are all those rules that we talked about? What happens if you've got parentheses, right? Distribute the 4 back in, okay? When you are dividing by the same base, such as in number 3, we got multiple rules going on there. So this is definitely one where I recommend going back to the video, going back to your binder, put all those rules on a help sheet. There's simply too many to go over in detail now. But PO15 is a big one. Definitely recommend looking at the video or your binder. Negative powers too, right? We got negative powers, like I said, 0 powers here, lots of stuff going on. In fact, I'm going to, before I forget, if I don't do it now, I know I will, add in the multiplication symbol so that when you receive this packet on the bulletin board in Blackbaud, it'll be perfect. Okay, PO18, function notation, f of x, g of x. There's basically 2 things that we're trying to do here, okay? Recall that f of x is really just a fancy way for the variable y. So this equation really says y equals 3x minus 8. And this equation really says y equals negative 9x plus 15. But the reason why we have f of x and g of x is so that I can simply ask you, what is f of 8? And not only do you know which variable I'm giving you, x or y, but you know which equation to plug it into, right? That's how function notation actually simplifies things. F of 8 means I want you to replace x with 8 in the f equation, right? So f of 8 means I'm giving you x in the f equation. So you would calculate 3 times 8 minus 8, 24 minus 8 is 16, and y is 16. Okay, when x is 8, y is 16. In the third one, it says find x when f of x, but remember, this is just a really fancy name for y. So really, this is saying find x when y equals negative 62. I mean, it literally tells you what variable that they're solving for, right? And then remembering that f of x just means y, I'm giving you that y variable. So again, in the f equation, this time I'm solving for x. So negative 62 equals 3x minus 8. right? Different strategy than in number one, both in the F equation, but asking you to do a different thing. I'm giving you a different variable. So I'd add 8 to both sides. That would give me negative 54 equals 3x. Divide both sides by 3 to get x by itself. And x is going to equal negative 18 for that one. So pay attention to what the question's asking you. Which variable are you being given? And then you can use that to get the variable that we want you to find. Next up, we have PO20, finding the slope of a linear function by interpreting a graph or using a formula. So slope, as we hopefully recall, is how a line moves across the coordinate plane. A very common kind of way to describe it is rise over run. What's the vertical change compared to the horizontal change, right? So if you look at this first line here, we have to pick out some ordered pairs to work with. So where does this line pass through a corner? Well, it passes through a corner right here, and it passes through another corner right there. Okay? You could also use this ordered pair down here if you wanted to. Would not make a difference. But what's the vertical change and the horizontal change between these 2 points? Well, to get from one point to the next, I'm going up 2 over 3, right? Up 2 over 3. So my slope, the rise is 2, the run is the run is 3, okay? So up 2 over 3, slope would be 2/3. Couple things to remember here. First of all, always read a graph from left to right. Start with the point on the left, go to the point on the right. And then if you're going up the y-axis, as I did in the first one, it's going to be a positive 2, positive rise. If I'm going down the y-axis, like I am in the second one here, I'm just going to plot a couple points on here. Point there. Looks like another corner right there. Here I'm going down. So it's going to be a negative 4 and then over 1. My slope would be negative 4 over 1. The change in y is negative because I'm going down the y-axis. Okay. And then for numbers 4, 5, and 6, I'm asking you to use a formula to find the slope because not all of us always carry around our pocket coordinate plane. And if you remember, each ordered pair is an x, y order. What we did was we labeled this first ordered pair x1, y1, our first x, first y, and our second x and second y, x2, y2. And the formula that we used, y2 minus y1 over x2 minus x1. And from here, it's just plugging those values in, right? y2 minus y1, 12 minus 7, x2 minus x1, 10 minus 3, and we get 5/7 for a slope, 5 over 7. If we could simplify that fraction, then we would. Since slope is a fraction, it should be in simplest form. We can't do it here, but if we could, then we would. Next one. Graphing an equation in slope-intercept form or standard form. So the top 3, or the first 4 actually, are in slope-intercept form, and then numbers 5 and 6 are in standard form. You have to do some conversion first. So basically, how slope-intercept form works, you're focusing on what is my y-intercept. That's the b in slope-intercept form. It's where you begin. Okay, so you're going to first plot your point on the y-axis at -2, and then use the slope, that n variable, to move up 3 over 5, rise over run. So from your y-intercept, up 3 over 5 is going to put us right here, and that's going to be the graph of that equation. Okay, so start with that y-intercept, and then use the slope to get that second point. In numbers 5 and 6, where the equations that you're given are in standard form, you first must convert them to slope-intercept form, which basically means get the y variable by itself. And your 2 steps to do this, number 1, move your x term over to the other side. You do that using opposite operations. Remember, you cannot combine 16 and -8x because the 16 doesn't have an x. And the way that slope-intercept form is written, that x term comes first. So it'd be -8x, right? The sign changes when you move it from the left to the right side there, -8x, and then a positive 16. Your second step would be to divide everything by that coefficient to y. So divide everything by -4. These cancel out here. And y is by itself. -8 divided by -4 is a positive 2x. And 16 divided by -4 is a -4. So y equals 2x minus 4 is what you're actually graphing. A y-intercept of -4 and a slope of up to over 1. So there's the conversion steps for standard form to slope-intercept form. Next objective, we have writing an equation in slope-intercept form, given its slope and a point on the line or a function table. So my recommendation for this one, you're going to be writing your equation in slope-intercept form, which means it needs to look like y equals mx plus b. Now, the y and x are always going to be in the equation as y and x in your final answer. So all you need to do is figure out what is my slope and what is my y-intercept. Sometimes I give them both to you, right? So this one is just as simple as plugging your slope in for m and your y-intercept in for b, and your answer is y equals 5x minus 1. Sometimes I might give you information you can use to find the slope and the y-intercept, but you'll need to do some of the work yourself, right? Slope of 2/3 passes through 15/6. So I'm giving you the slope, so we can start by plugging 2/3 in for m. And this ordered pair is actually pretty important because remember, ordered pairs are the values for x and y. So because I'm not giving you the y-intercept, you have to solve for it. You're going to use that ordered pair. 6 is our value for y, so that goes in for y. 15 is our value for x, that goes in for x, and you're solving for b. You're solving for b. Take care of the right side first. 2/3 of 15 is 10. And then move the 10 over using opposite operations, subtract 10 from both sides, and we get -4 as our value for b. So our final equation, y equals the given slope, 2/3, x minus 4. Like I said, y and x will always be y and x in your final answer, but you might have to use them to solve for b as we had to do in number 2. Numbers 3 and 4, I give you an XY table, meaning that you kind of need to use those ordered pairs to find your slope. All you need to do is pick 2 of them. They're both positive, so we'll go with those there. And use your slope formula from the previous page to find what the slope is. Subtract the y's, 6 minus 4 is 2. Subtract the x's, 2 minus 6, -4. So our slope, rise over run, 2 over -4, that is equivalent to -1/2. That's the slope that we would use. And to solve for b, you've got 4 different ordered pairs. You can pick any of them from the table. 4 different ordered pairs to choose from to solve for b. So just like we did in number 2, you take that slope that we just found, this -1/2, and an ordered pair from the table, pick any of the 4, plug all that into your equation to solve for b. Numbers 5 and 6, I give you 2 ordered pairs to pick from. So you'd find the slope using the formula, y2 minus y1 over x2 minus x1, and then plug either of those ordered pairs in to solve for b. Okay? So all kind of similar, just giving you the information in a different way. PO28, determining if lines are parallel, perpendicular, or neither. Remember that parallel lines will have the same slope. Perpendicular will have what's called negative reciprocals or exact opposites. So if the slope of one line is, I don't want to use one I use on here. The slope of one line is 3/7. The negative reciprocal, or the exact opposite of that, means you flip the fraction and you change its sign. So a perpendicular slope would be -7/3. That's what you're looking for there. And then if the slopes aren't the same, or they're not negative reciprocals, then they're neither. They'll still intersect, but they're not parallel, they're not perpendicular. So the first one, line A, the slope is 3. Line B, the slope is 1/3. Are 3 and 1/3 the same? No, so they're not parallel. Are 3 and 1/3 negative reciprocals? No, right? 1/3 is the reciprocal of 3, but it's not negative, so it doesn't quite fit everything to be perpendicular. Therefore, these slopes would be neither. The second one, 4/5 and -5/4 are the slopes that we are looking at here. The y-intercept doesn't matter at all. We're using just the slopes. 4/5 and -5/4, they're obviously not the same. -5/4 is the negative reciprocal of 4/5. The fraction has been flipped, the sign has been changed, therefore these are perpendicular. Okay. Then for 3, 4, 5, and 6, again, I'm just giving you the information in a different format. Line A passes through 5, 7, and 18 at -2. How do you find the slope of line A? Use the slope formula. How do you find the slope of line B? Use the slope formula. Then compare the slopes. The same, negative reciprocals, or neither. 5 and 6, I'm giving you the equations in standard form, so you need to convert them to slope-intercept form. Pay attention only to the slopes. Y-intercepts do not matter. Slopes only. Are they the same? Negative reciprocals? Neither. Okay, it's just same concept, information given to you a little bit differently. Okay. Next one, solve a multi-step inequality. Very similar to equations here. The only thing is when you're all done, you have to graph your solution. So for example, number 2 here, I see parentheses. I know I'm going to be distributing that 12 in. That gives me 12x plus 84 is less than or equal to 24. And I'm going to solve this very similarly to how I would solve a 2-step equation. I'd start by subtracting 84 from both sides. Start with that constant, opposite operations. That gives me 12x is less than or equal to -60. And now to get x by itself, I divide both sides by 12. And x is less than or equal to -5. I'm not done yet though, right? Because I need to now show what the solutions are on a number line. Because saying that x can be anything less than or equal to -5, that's a lot of different options. Could be -4. Not just kidding, that's greater than -5. Could be -6, -7, -8, -9, right? So on the number line, what you do, you kind of stick -5 in the middle, and then above that, you're either going to put an open circle or a closed circle. Because my inequality statement here includes that or equal to part, it's not just less than, it's less than or equal to. I want to put a closed circle above -5. If it was just less than, or if it were just greater than, it would be an open circle, right? But it has that or equal to piece, so the circle's closed. And then which side of -5 are the values less than? To the left. So you can put an arrow pointing that direction, you can kind of shade that direction, whatever you want to do to show me that that's the side of -5 on the number line where my solutions are. -6, -7, -8, -9, etc. The one kicker to this when you are solving inequalities, let's just say that in this first one, this was a -5x. It isn't, but let's just say it was. So first we'd add 12 to both sides, and that would give us -5x is less than +20. Remember, there's something a little bit quirky about this step when you need to divide, or if we had to multiply by a negative number. When we do that, our inequality symbol flips. So it starts out as a less than sign, but because we divided by a negative number, it now becomes a greater than symbol. So my final inequality statement would be x is greater than -4. And it's because I had to divide by that -5. And now when graphing this, -4 goes in the middle. This time it's an open circle because it's just greater than, doesn't have that or equal to piece, and greater than is to the right on the number line. So the original inequality does have a +5x, but I just made it negative just to show you, remind you what would happen if you were to divide by a negative number. Okay? All right, moving on. Call me Tom, because we are cruising. PO39, interpreting a scatter plot. Remember with scatter plots, we use them to kind of look for relationships, look for correlations, look for trends. So first you need to identify whether each scatter plot has a positive correlation, a negative correlation, or no correlation, no relationship at all. And then assign these labels down here to which of those three scatter plots it would belong to. Car weight and miles per gallon. Okay, which one would show that, if we assign car weight to A, that would mean that as car weight increases, miles per gallon increase as well. Is that relationship true? Or is it not? As car weight increases, miles per gallon it kind of goes all over the place, right? So that would show that there is no relationship between car weight and miles per gallon. Is that the case? Or option C, as car weight increases, miles per gallon kind of seems to be going down, right? Is that relationship true? Okay, so identify what type of relationship, what type of correlation each one has, and then assign these labels to which scatter plot they each belong to. Now we're getting to some fun stuff. This is the ones that are going to take me a little bit longer to explain, I think. Solving a system of equations using elimination. The patented way that we talked about this during the year, Ox and Oi, right? You want to get 0x or 0y. So a system of equations is two equations, each containing two variables. And we're looking for the one value for x and the one value for y that makes the equation true. And so numbers 1 and 2 are kind of set up for you already to move into elimination because of this. Remember, you want your coefficients on one variable to be the same. Okay, in the first one, it's 2y and 2y. In the second one, it's negative 6x and negative 6x. When that happens, when you've got that, you can just go ahead and subtract the equations to cancel that variable term out. 7x minus 8x is a negative 1x, or just negative x. And 2y minus 2y gives us oi, right? 0y. They cancel out. And then 24 minus 30 is a negative 6. And from here, we can get x by itself, divide both sides by negative 1. Negative 6 divided by negative 1 is a positive 6, and that would be our solution. We're not done yet, though, because now we have to go back and plug 6 in for x to solve for y. Doesn't matter which equation that we use. I'll just go with the top one. So 7 times 6, because we know what x is now, we can plug that in there, plus 2y equals 24. 7 times 6 is 42. Plus 2y equals 24. Subtract 42 from both sides. We get 2y equals negative 18. Divide both sides by 2. And y is a negative 9. So x is 6. Y is negative 9 in the system. Though that's the one value for x and the one value for y that's going to make the system work. Like I said, number 2 is already set up for you as well. Numbers 3 and 4, though, there's a little bit of extra work that you need to do because you don't have like coefficients on either variable, right? So you have to make them like coefficients. Looking at number 3, which pair of variables is it going to be easier to make the same? 16x and negative 8 or negative 10 and negative 6? Well, I'm going to go with 16x and negative 8 because negative 8 goes into 16, right? All I have to do is multiply by negative 2, making sure I multiply everything by negative 2 in that equation to get it to match up. So my first equation doesn't change. 16x minus 10y is still 10. My second equation, negative 8 times negative 2 is a positive 16x. Negative 6 times negative 2 is a positive 12y. And 6 times negative 2 equals negative 12. Don't forget about that constant. You have to multiply that by something as well. Now they're set for me to go ahead and subtract. This time I get aux. All right, these cancel out. Negative 10 minus 12 is a negative 22y. 10 minus negative 12, don't forget to go back to this symbol, okay? And don't forget about this symbol here too, right? 10 minus negative 12 is a positive 22, and I can now solve for y, take that value, plug it back in, solve for x, and that would be my solution. And then a similar setup here with number 4. 5 and 6, excuse me, you get to set up the equations yourself here. You go to a concession stand in a football game and buy 3 hot dogs and 4 drinks for a total of $20.75. You go again later and buy 2 hot dogs and 3 drinks for a total of $14.75. How much is a hot dog and how much is a drink? Well, last year we talked about first identify variables. H, hot dogs. D, drinks. Okay. Next, we want to identify the totals. $20.75 is a total. I don't need to write the dollar sign if I'm writing an equation. It's only going to complicate things. $20.75 is a total. Now, what makes up that total? How did you get there? Well, you bought 3 hot dogs and 4 drinks. 3 hot dogs, 4 drinks equals $20.75. Then later, you spent $14.75. That's another total. What did you buy? Well, you bought 2 hot dogs and 3 drinks. Now you've got your system. Now it's just like what you did in numbers 1, 2, 3, and 4, where you want to get the coefficients the same. It looks like in this case you have to multiply both equations by something to get that like coefficient. Maybe you want to, make your h coefficients into 6s. You have to multiply the top equation, everything, by 2. The bottom equation, everything by 3 to get 6. Or maybe you want to turn your d variables, your coefficients into 12. Right? Multiply everything in the top equation by 3 to get 12d. Multiply everything in the bottom equation by 4. And then you can solve from there. So 5 and 6, you set up the equations yourself and then go through that solving process. 47, multiply a monomial by a polynomial. This is simply just the distribution property, just bigger, right? When we distribute 3x into 4x squared, into 2x, into positive 3, we're multiplying 3x by each of those terms. So 3x times 4x squared is a 12x cubed. Remember, this x has an invisible power of 1 on it. So 3 times 4 is 12, and those exponents get added. 1 plus 2 is 3, right? 3x times 2x is 6x squared, and then 3x times 3 is 9x, and we'd be done. Okay? If you recall, this was the math that kind of looked a lot more complicated than it actually is once you kind of get what's going on here, right? But yeah, you're distributing into the parentheses, coefficients get multiplied, exponents get added, and then once you're done, there's no equal sign, nothing to solve for here. And so that would be our final answer. Next one, really excited about this one, and you should be too, because it is the return of Old Man Foil, or Crab Claw, or the box method, right? Any of them are going to work. I'll do an example of all 3 of them on the same one. Well, maybe not the same one. I'll do 2 of them so you can kind of see how this works out. So x plus 3, x plus 4, using Old Man Foil. Basically, Old Man Foil and Crab Claw are just different ways to draw the same lines. Essentially, what we want to do here is we want to multiply everything in x plus 3 by everything in x plus 4. So the x gets multiplied by the x. That gives us x squared. The x gets multiplied by the 4. That gives us 4x. The 3 gets multiplied by the x. That gives us 3x. And the 3 gets multiplied by the 4. That gives us 12. Right? Hey, old man! Smiling back at you for a job well done. The final step is combine the like terms that you can there. 4x and 3x give us 7x. And so your final answer is x squared plus 7x plus 12. Okay. Same thing using crab claw. X plus 3, x plus 4. Crab claw, the line's just drawn differently. Instead of, our first one, x times x still gives us x squared. Instead of drawing the line underneath now, we draw it up top to make a claw-like shape. X times 4 is still 4x. Then with the 3, we go underneath. 3 times x is 3x, and underneath again. Crab claw! And we have 3 times 4, which is 12. Still the same results. We still combine 4x and 3x to get 7x, and our answer is still x squared plus 7x plus 12. If you're not all about that, if you don't like drawing pictures, if you don't think they're very clever, you also have the box method, right? And the box method, I'll do that with the second one here. We have a 2 by 2 expression, a binomial times a binomial. So we're going to make a 2 by 2 box. And one expression goes across the top. Doesn't matter which one. One expression goes down the side. And we just fill in the boxes now. 2x times x is 2x squared. X times negative 1 is a negative 1x. 2x times 8 is 16x. 8 times negative 1 is negative 8. Right? We look for the terms that we can combine now, which in this case are those x terms. 16x minus x is a positive 15x, and then minus 8. And this would be our final answer there. So you got 3 methods here. Maybe do each method on 2 of them. Old man foil, crab claw, box, and that is PO 48. Continuing with, I should mention also, numbers 5 and 6 do not fall into the trap of distributing this exponent into the parentheses. You can't do that because you're adding. That plus sign kind of makes that mathematically illegal to do. What this says, what's being squared, is the sum of x and 3. So you're going to need to rewrite this out in expanded form, x plus 3 times x plus 3, and then foil, crab claw, box. Okay? If you distribute that exponent in, you're going to get the incorrect answer. So instead, write it out, foil, crab claw, box. Next up, we get to factor trinomials, starting with x squared plus bx plus c form. This is the one where you are focusing on your constants and your middle term. Okay? Because our coefficient's x squared, we don't really have to pay attention to it. We're looking at our constant and our middle term. And we're looking for 2 numbers that multiply to make our constants, and those same 2 numbers add to equal our middle term. So what are factors of 77 that also add to be 18? Well, 7 and 11 is the magic combo. So what do we do with that? Well, we're going to make 2 sets of parentheses. Each one is going to start with an x, and then one gets a positive 7, and one gets a positive 11. And we're done. X plus 7 times x plus 11. Basically doing the opposite of what we did in PO 48 with old man foil, crab claw, boxing. Right? We started with the 2 sets of parentheses. You got the trinomial expression. Now I'm giving you the trinomial. You're telling me what 2 sets of parentheses would multiply to make that. So essentially the opposite of what we did in PO 48. There may be some that are not factorable. If you cannot find a combination of numbers that work here, it just might be a non-factorable equation. That happens. Okay? But you got to make sure that you exhaust all possibilities for those factors of 77. There might be one where you need to move a term over first, such as, let's do the bottom one here. X squared plus 49 equals 50x. In order to factor this should equal 0, which this one doesn't. So first, we have to move our 50x term over to the other side and make sure we put it in the right place. Right? Since it's my x term, it's going to go in the middle. And since I moved it over from one side of the equation to the other side, the sign will change. On the left side, it's now a negative 50x instead of a positive 50x. So what am I looking for? I'm looking for two numbers that multiply to make 49, and those same two numbers add to be a negative 50. So you can really give the numbers any sign that you want to, right? What are factors of 49 that I can use to make a 50? Well, my factors of 49 are either 7 and 7 or 1 and 49. That's my combination there. How do I get a negative 50 out of that? Well, a negative 1 times a negative 49 equals a positive 49, and a negative 1 plus a negative 49 equals a negative 50. So x minus 1, x minus 49 would be my answer. Okay? PO52 are where things really get fun, because now we throw in that coefficient to x squared. Okay, this is that 7-step process that I highly recommend you go back to the video, go back to your binder, write those steps down, practice, practice, practice here. We'll do the first one. Our first step is to pull out that greatest common factor. Right? And the GCF of 16x squared and 12x and 18 is a 2. So I'm going to rewrite this to be 2. My 16x squared now becomes an 8x squared. My negative 12x becomes a negative 6x. And my negative 18 becomes a 9. Right? I factored a 2 out of all of them, essentially divided them each by 2. Step 2, because I have that coefficient to my x squared term, here's where I multiply my a and c term together. In my a and c term, I don't go back. I'm kind of done with this for now. Once I factor out that greatest common factor, I'm done with that. If I couldn't factor out a greatest common factor, like in the third one here, then I'd still have to use that original equation. But because I factored out the 2, I'm going to ignore what I had originally and focus on what's in my parentheses now. That my a term is 8, my c term is negative 9. And the product of those two numbers is negative 72. I can write that a little bit neater. Negative 72. Okay. Step 3, I kind of go back to what I did in PO 51. I'm looking for two numbers that multiply to make that negative 72. And those same two numbers add to equal my middle term, negative 6. What's the combination? 6 and negative 12. 6 times negative 12 is negative 72. 6 plus negative 12 is negative 6. Okay. Now, just for space-saving reasons, because I have to write a lot bigger than you do, I'm going to move to the right here for steps 4, 5, and 6. But you can just continue with your work down so you have room for number 2 as well. But step 4, where I start to set this whole thing up, I've got my greatest common factor, that 2, and then my 2 sets of parentheses. Remember, we're going to start each of them the same way. I'm going to take this 8 from my parentheses, that a term, and put it in both sets. The reason why I do this is so that now it doesn't matter which one gets my positive 6 from step 3 and which one gets my negative 12 from step 3. If we start the parentheses the same, it doesn't matter where we put the 6 and the negative 12. That is kind of breaking the rules a little bit, but remember, we fixed that now by step 5, simplifying. I can divide 8 and 6 by 2. I can divide 8 and 12 by 4. And remember our little checkpoint here. These numbers that we divide by should multiply to equal that extra 8 that we put in there, which they do. Okay. So now my expression looks like, again, my GCF out in front. 8 divided by 2 is a 4x. 6 divided by 2 is 3. 8 divided by 4 is a 2x. And negative 12 divided by 4 is a negative 3. Step 6, I distribute this 2 into the first set of parentheses only. It so happens that it kind of brings me right back to where I was in that first set. That won't always happen. If it does, it's fine. And this is my final answer. And I can check this by foiling, crab clawing boxes, and it should equal my original expression. 8x times 2x is 16x squared, checks off. 6 times negative 3 is a negative 18, checks out. And if I do my inside-outside, negative 24x there, positive 12x here, negative 24 plus 12 is a negative 12x. That checks out as well. So, woohoo! It's big stuff, right? So go back to the binder, look at the video, write down the steps. If you haven't memorized, even better. But if you need the help, please take the time, put that in ahead of time so you're not having to retake this. Next objective, 54. We now move to parabolas, graphing a parabola. This is the one. What do we know about parabolas? Well, they make a U shape or an N shape, like a smiley face or a frowny face. We know they're symmetrical, and we know we need 3 points to graph them. We have the y-intercept, the vertex, and the reflection point, right? The y-intercept just comes from our c value in the equation, which in this case is going to be positive 2, right? Our c value is in that equation is positive 2. Our vertex point is where we get to have a lot of fun. This is an ordered pair, and to get the x value, we use the formula negative b over 2 times a. Negative b over 2 times a, right? So in our equation, our b value is a negative 6. So we have a negative 6 divided by 2 times our a value, 3. Well, a negative 6 is actually a positive 6. 2 times 3 is 6. That simplifies to be 1. Right? A, B, and C. A, B, C. Right? And so the x value of our vertex is positive 1. How we get the y value is we go back to our original equation, and notice how it literally says y equals 3x squared minus 6x plus 2. Well, guess what? Now we know what x is. X is 1. So that means that y is going to equal 3 times 1 squared minus 6 times 1 plus 2. You can put this directly into your calculator. Okay, be careful of parentheses, order of operations, all that stuff. But you should get, let's see, 3 minus 6 plus 2. Y is going to equal negative 1. Okay, y is going to equal negative 1. All right, let's plot what we already have. 0, 2, our y-intercept is right there. 1, negative 1, our vertex is right here. Now, knowing that this parabola is symmetrical, our third point, that reflection point, remember, is directly across from our y-intercept on the other side of that imaginary axis of symmetry that goes straight through the vertex. So across from our y-intercept on the other side of the axis of symmetry, it's going to go right here. That's that third reflection point. It makes the parabola symmetrical. We connect all the dots in a nice U shape. Whoops. And we can just do a quick check, see if we're on the right track here. This parabola opens upward. And remember, since our a term is positive, that tells us it is going to open up. If a term is negative, that means it's going to open down. So I like what I see here. A positive a term, it opens up. That is a good thing. So graphing parabolas, lot to it. There's an example of one. Again, go back to the binder, check it on YouTube, practice these, and there you go. PO55. Ooh, a 2-pager. There we go. PO55. Solving a quadratic equation using multiple factoring methods. Here's where, when we talk about solving a quadratic equation, we're finding the x-intercepts of the parabola, right? We're looking for where the parabola crosses the x-axis. This objective, similar to that exponent one from earlier, it kind of has multiple different methods that you can use. So I recommend going back to the binder for it or watching the video on it. You essentially have 3 types. Numbers 1 and 2 are in y equals ax squared plus c form. And your method for this one is opposite operations. You only have one x term, so you want to use opposite operations to move everything else on the other side of the equation. And remember, your final step is to take the root of that x. So like this one, you'd start by adding 400 to both sides. 4x squared equals 400. Divide both sides by 4. X squared equals 100. And this final step now, us PERMDAS people know exactly what to do. We root both sides, cancel that exponent out. And the thing that often gets missed, the root of 100 technically has two answers because parabolas can have two x-intercepts. It's positive and negative 10. Positive 10 times positive 10 is 100. Negative 10 times negative 10 is also 100, right? And you need them both. And that's the math symbol to kind of include them both. Numbers 3 and 4 are in the form y equals ax squared plus bx. And this one, your method is to factor out the greatest common factor. Factor out the GCF. So in the first one, number 3 there, the GCF of 6 and 18 is 3. Or I'm sorry, 6. So if we put a 6 out in front along with an x, because x goes into each of them also. Okay, so your GCF of the expression is 6x. And when we do that, we're left with 6x squared divided by 6x is just an x. And 18x divided by 6x is a 3. Remember, you can check this by distributing that 6x back into the parentheses and make sure that you get what you originally had, 6x squared plus 18x. Now, what we're looking for, since this equation equals 0, we want to know what value for x makes each of these pieces equal to 0, because we're multiplying them together, right? 6x times x plus 3. And when you multiply something by 0, the answer is always 0. So what value for x makes 6x equal 0? That's your freebie. Remember, this one's got a freebie. In this form, 1x will always be 0. The other one, negative 3 plus 3 equals 0. So x equals negative 3. And those are your two solutions. Numbers 5 and 6, you can factor. This is in the form y equals ax squared plus bx plus c. I recommend you just straight out factor, as we did in PO51 and PO52. Your other option, which will work for all of these, if you're like, yeah, this is too many methods, too many things, the quadratic formula will work for all of them, which happens to be our next objective, PO59. The quadratic formula, okay? This will work to factor any quadratic equation, even all different types of forms. And let's not do the first or second one. You always say the first and second one are the easiest. Let's do one that is not the easiest. Let's do number 4 here. Actually, let's get some negatives. Let's do number 3 and big numbers also. So the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Okay? And just like in previous objectives, our a, our b, and our c, a is the coefficient x squared, b is the coefficient to x, and c is the constant. Some folks find it helpful to write those values down along the margin here. You just have them. You're not going back to the equation constantly. So a is 10, b is negative 94, c is negative 300. All we got to do is plug these into the equation, right? So a negative b, a negative 94 is going to make it positive. The negative sign in the formula and the negative sign with the 94 will cancel out. Positive 94 plus or minus the square root of negative 94 squared minus 4 times a, which is 10, times b, which is negative 300. My streak continues of never making this long enough. Okay? 4 times a times c, all divided by 2 times a, or 2 times 10. And remember, we evaluate this in pieces, okay? First, we're going to figure out what this is. We're not going to take the square root yet. We're going to figure out what that is. So 94 plus or minus the root. In my calculator, I'm going to take negative 94. Make sure you put it in parentheses, okay? Negative 94 squared minus 4 times 10 times negative 300. If you do that calculation correctly, you should get 20,836. Okay, so we're taking the root of 20,836 divided by our denominator. Let's also simplify that because that one's easy to do. 2 times 10 is 20. Okay, and let's see. The root of 20,836 is 144.34, blah, 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 blah. It doesn't work out evenly. That's okay. Okay, that's okay. We're going to write that as round to the nearest hundredth. So you have 94 plus or minus 144.35. And again, I got that 144.35 by just taking the square root of 20,836. Use a calculator to do that. I get this answer. So now what do I do with this? Remember that a parabola can have two x-intercepts, right? This is where the plus minus sign comes into play here. One x-intercept is going to be 94 plus 144.35 divided by 20. The other x-intercept is going to be 94 minus 144.35 divided by 20. Order of operations, be very careful here. The way this is written, that 94 plus 144.35 has to be done first. So put that in parentheses, then divide that by 20. One answer is 11.92. If you don't get that, check your order of operations. 94 minus 144.35 divided by 20. The other x-intercept is negative 2.52. And this is why you can use a calculator on the entrance exam, right? Good idea to check this. I'm going to take this 11.92, go back to my original equation, and rewrite it with x replaced with 11.92, right? I don't want to put 11.92 in for one x and then negative 2.52 in for the other x. That's not quite what this is saying here. It's saying that if x is 11.92, that's going to give us 0 or very close to it. Or if I put in negative 2.52 for both x's, that will also get us to 0 or very close to it. Let's see how close we get here. It's not going to be exact because remember we did round. So that's going to throw off our value slightly. But with 11.92, I get 0.384. That is close enough to 0 for me to be confident that this answer is correct. And if that answer is correct, it's likely the other one is too. And so, behold, the quadratic formula. Definitely something you want to put on a help sheet. My count tells me we're on the last power objective here, PO61. Yes, we are, simplifying radical expressions. And there's a lot to this one too, right? There's a lot to this one too. In fact, in our binder last year, PO61 had 3 parts to it. We had simplifying just kind of general expressions. We had rationalizing the denominator, and we had variables. So I'll kind of go over one of each here, okay? The root of 40, our strat for this. Break this up into 2 factors of 40, one of which is a perfect square. So I don't want to use 20 and 2. I don't want to use 8 and 5. I want to use 4 and 10 because 4 is that perfect square. The reason why I want that perfect square is because I can simplify this down to 2, right? The root of 4 is 2. The root 10, nothing to do with that. Don't care. My final answer is 2 times root 10. That's as far as I go. Okay? When we have a fraction, remember the math hack for this is we can split this fraction up into our numerator and denominator separately, so we can just focus on one of them at a time. Luckily for us, root 25 is already a perfect square. So that just simplifies to be 5. Our root 7 doesn't have any perfect square factors, so normally we just leave it as root 7. However, it's in our denominator of a fraction, which is where that whole rationalizing the denominator kicks in. Okay, we cannot have a root in our denominator of a fraction. So what do? We multiply by root 7 over root 7, right? Multiply by that root over itself. Our numerator, 5 times root 7, just becomes 5 root 7. We can't make a root 35 or anything because one's under a root, one is outside the root. In our denominator, what ends up happening is those roots cancel out, right? Because really, root 7 times root 7 is root 49. Those can be combined because they're both underneath the root. And the root 49, we've made a perfect square. Root of 49 is 7. And this would be our final answer. We can't do anything with the root 7 up top and the 7 down below because, again, one is inside the root, one's outside the root. So 5 root 7 over 7 would be our final answer. Okay? With variables, we have a whole chart in your, let's do number 5. You have a whole chart in P.O.61 that tells you kind of what to do, how to handle the root of variables with various powers. And for starters here, let's break this up. Like a fraction, we can separate this into root 49 times the root of x to the 4th times the root of y cubed. And we're going to take each one separately. The root of 49, perfect square, yippee, that becomes 7. Root of x to the 4th, remember that even power means the perfect square. And all we have to do is divide by 2. Okay? The root of x to the 4th is equal to x squared, because x squared times itself, x squared times x squared equals x to the 4th. The root of y cubed, that odd power, remember we can break this up into root y squared times root y to get that perfect square factor right here. The root of y squared is just y, and the root y we can't do anything with, and we don't care. Remember, the rule for an odd power is kind of subtract 1, then divide by 2, and then you have that extra root y hanging on. So our final answer, 7x squared y root y. Okay? Again, definitely something worth putting on a help sheet, reviewing P.O.61, both the binder and the video. And that wraps up the entrance exam review packet for geometry. Please put the work in on the front end. Going through my program, 7th grade, you hopefully saw the value of doing the work on the front end, so you don't have to spend all that time with practice work and retakes and things like that. But again, I'll reiterate here, these are skills that knowing them is going to make geometry go much better for you. They're the most important things from algebra that you need to be carrying with you. So answers will be posted in Blackbaud on the bulletin board on August 29th. Thanks very, very much. Contact me if you have any questions. Have a great day. Like and subscribe. Bye.